So I have a question I'd like us to ponder. Is it possible to find the product of the roots of quadratic equations? Remember, it's quadratic, so there are only two roots. So is it possible for us to find the product of the roots of quadratic equations without having to solve completely the quadratic equation and then get the roots and then multiply them together? The answer to that is yes, and I'm going to show you exactly how to work with that. And so here's how we're going to do it. We're going to talk about the standard quadratic equation. We're going to talk about the roots of quadratic equations. And then I'm going to actually derive the product of the roots of quadratic equations for you. And we're going to do it together. And then I'm going to show you how you can apply this to actually calculate the product of the roots of quadratic equations without having to solve the quadratic equations completely and then multiplying toward the end. And then after that, we're going to apply these steps with some examples that we have already prepared. So here's a standard quadratic equation: ax squared plus bx plus c equal to 0. Remember that it's equal to 0 because it's an equation. It has to be equal to a value, but in the standard quadratic equation, that value must always be equal to 0. And so a, b, and c are what we call the coefficients, and then a and b are coefficients of your algebraic term, and c is your constant. So a is the coefficient of your quadratic term, b is the coefficient of the linear term, and c is the constant. So when we have a quadratic equation, we have this quadratic formula that we can use to get the value of the roots of the quadratic equation. And this is very important because I'm going to show you how you can actually use this to get the value of, to actually get the formula for deriving the product of the roots of quadratic equations. So here's what the formula looks like. This is the quadratic formula. So it's x equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. You can see that all we're working with here are simply the coefficients and of the algebraic terms and the constant value a, b, and c. So let's go ahead and derive the product of the root of quadratic equation. So like we showed earlier, x equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So what we're going to do here is we're going to make some good assumptions here. And one of them is we're going to say that suppose that we have two roots, and our roots here are going to be alpha and beta. These are going to be the two roots. Let's use a comma here to show that. Yes, we use a comma here. So we have alpha and beta. So alpha is going to be negative b plus the square root of b squared minus 4ac over 2a. And then beta is going to be the negative one here, which is negative b minus b. And this is going to be minus, this is minus the square root of b squared minus 4ac divided by 2a. So we want to find the product of this root. So the product of this root is going to be alpha multiplied by beta. So what we're going to do now is we're going to multiply this together. So we're going to have negative b plus or minus, rather, it's negative b plus, for alpha, negative b plus the square root of b squared minus 4ac over 2a. And this is going to be multiplied by negative b minus the square root of b squared minus 4ac over 2a. So something important that we have to bring to your recollection, or to our recollection as we walk through this, is we need to remember that a plus b multiplied by a minus b equal to a squared minus b squared. So you can see here our terms are pretty much the same. The only thing that changes is the sign in the middle. So what we're going to end up with is something that looks like this. We're going to apply this. We're going to see something that looks like this. Negative b, remember here, this is going to be, this part of it right here is going to be our a. This part right here is going to be our b. So you can see here a, and then this is going to be our b. Can you see that? So you have a plus b, a minus b. So it's going to be a squared. So we have negative b squared minus, and then we have the square root of b squared minus 4ac squared, and then we're going to divide by 2a squared. So now let's go ahead and simplify this. We're going to end up with b squared, and then we have minus here, and then we have b squared minus 4ac. And the reason why we can do this is because when you have a square root and you square it, all it does is removes the square root sign, and then we have divided by 4a squared. So let's go ahead and keep simplifying. So we have b squared minus b squared plus 4ac divided by 4a squared. So this is going to give us b squared minus b squared, 0. So we have 4ac divided by 4a squared. So this is going to cancel out. This a right here is going to cancel one of this, and so we have c over a. So therefore, alpha multiplied by beta should give us c over a. So that simply means that the product of the root of a quadratic equation can simply be derived if you find the value of c and the value of a and you divide c by a. So let's talk about the steps. So we want to compare, when we want to find the product of the root of quadratic equations, these are the steps we're going to take. First of all, we need to always compare the equation we have with the standard quadratic equation. And when you do that, we want to find the values of a, b, and c, and then we're going to substitute those values into this equation right here. Alpha multiplied by beta, which means the product of two roots, is going to be c over a. So let's apply this as we solve some examples. What is the product of the roots of 2x squared plus 9x minus 16? So I like to make this a habit. So I have ax squared plus bx plus c equal to 0. So what we're going to do here is a is equal to 2, b is equal to 9, and c equal to negative 16. And we know that alpha multiplied by beta is going to be c over a. And so let's go ahead and substitute the value. C is equal to negative 16. A is equal to 2. So this is going to give you negative 8. So that means that the product of the root of this quadratic equation is going to be negative 8. Look at how much time it saves you. You don't have to worry about deriving the formula for, you don't have to worry about plugging all of this into the quadratic formula, get the roots, and then have to multiply them later on. So this saves you a lot of time as you work with quadratic functions. Now let's take a look at this other example. So we always remember that we're comparing with the function, or the quadratic equation we have is 16x squared minus 49 equal to 0. So what we're going to do here is we're always going to pay attention to ax squared plus bx plus c equal to 0. So you can see here that we have a quadratic term, we don't have a linear term. So what I'm going to do, just as a practice as you learn how to work with quadratic equations and the standard quadratic equation. So what I'm going to do here is I'm going to write it in this form. So this is going to be 16x squared. Because we don't have a linear term, I'm going to make it 0x, and then we have minus 49 equal to 0. So now you can see that it's easier to compare. So we can see here that A is equal to 16, B is equal to 0, and C is equal to negative 49. And then this product of our roots are going to be C over A, which is equal to negative 49 over 16. And that is going to be the answer to that question. Now let's go with one final equation. Let's go ahead and compare. We have ax squared plus bx plus c equal to 0. So here we have a equal to 5, b equal to negative 9, and c equal to 10. So what we need to do here is remember that the product of the roots of a quadratic equation equal to c over a, which is equal to 10 over 5, and that is going to give you 2. So the product of the roots of this quadratic equation is 2. And you can see how much time this saves you once you understand how to do this. It's going to save you a lot of time. It's going to make sure that you can get to these answers a lot quicker. And trust me, when you have to deal with the quadratic formula, it could be easier to make some mistakes using the quadratic formula and trying to get the value of each of the roots before you multiply. This is the most error-free way to get the product of the roots of any quadratic equation.